So now a new problem. A block of mass 1 kg, it is released from point P here on a frictionless track which ends in a quarter circular track of radius 2 meter. What is the magnitude of radial acceleration and total acceleration when it arrives at point Q? Now there are a few things. One thing is they have given you the mass and it has been released from a point P which is at a distance 6 meter from the ground. Now that slope, the slope ends here and now it gets continued with this quarter circular track. They have said it ends in a quarter circular track of radius 2 meter. So what do you expect to happen? Whatever is the potential energy at this point, okay, what about kinetic energy? Initial kinetic energy is 0. They have said it is frictionless, correct? So whatever is the potential energy at point P, it is going to get converted into kinetic energy and total energy at point Q there, right? Do we know the velocity at point Q? We don't know. Do we know the potential energy over there? Yes, this is radius is 2 meter and it is a quarter circular track, so even this is 2 meter, right? So how can we handle this problem? What is expected? They want us to find the magnitude of radial acceleration. So when we say radial acceleration, it is centripetal acceleration at that point, and centripetal acceleration or AR, radial acceleration, what is it? Is it not v square upon r, right? So we are expected to find this here. Now how do we do this? What I'm going to do is total energy at P is equal to total energy at Q. So I have no kinetic energy here in the beginning, so I have only PE at P is equal to, now here the total energy would be equal to the kinetic energy plus potential energy, so it would be PE at Q plus KE at Q, correct? So now I have M G into H is equal to potential energy would be mg into r plus half m into how much is your v square, that we don't know, that is what we need to find out. I know r, I know m, but anyway you can see here that mass is getting cancelled on both the sides, correct? So now let us substitute. So g into 6 is equal to g into 2 plus v square upon 2, correct? So 6g is equal to 2g plus v square upon 2. So my v square is going to be equal to 8 times g, correct? Now you'll be wondering why I have not calculated v here, v square. Have they asked you to calculate v or v square? No. So let's not waste energy in that. So let us go to this radial acceleration. Now here you need to find the radial acceleration, correct? So radial acceleration would be equal to v square upon r, and that is equal to 8g upon radius is equal to 2, so that is equal to 4g, and 4g would be equal to 4 into 9.81, so that would be equal to 4239 here, 39.24 meter per second square. So that is one part. What is the magnitude of radial acceleration and total acceleration when it arrives at point Q? Okay. Alright, we have found the radial acceleration. What about total acceleration? Is there any tangential acceleration at point Q? Yes, the answer would be yes, because over here, suppose this is your point Q and this is your radial acceleration. There is gravitational acceleration which would be acting vertically downwards, right? So if this is 4g and this is g, then your resultant acceleration would be, it would be acting somewhere here. You would be just completing this parallelogram, right? So it is going to be 16 g square plus g square, and root of that would be my total acceleration. So root 17 into g, that would be equal to total acceleration. Now this root of 17 is going to be just greater than 4, because 17 is close to 16. 16 has got square root 4, so root of 17 is going to be just greater than 4, and that multiplied by g, so it is going to be marginally greater than this 39.24. It would be something like 40 point or maybe 41 point something there, which you can calculate on your calculators, right? Thank you so much.